Do you know what are the spallation reaction? And if you are searching the difference between artificial radioactivity and transmutation, then this video is for you. In this video, we are going to discuss nuclear transmutation and nuclear reactions. Hello, students, welcome to GS Academy, and let's start the reaction. Okay, the first one is nuclear transmutation. What nuclear transmutation is? Actually, it is an artificial phenomena by which one nucleus is transformed in another nucleus by artificial means. It is different from natural radioactivity as it is artificially done in stable nuclei. We know that spontaneous decay of unstable nuclei is known as natural radioactivity, while artificially done decay of an stable nuclei is known as transmutation, because the parent nuclei is converted to the daughter nuclei, which are different to each other. So that's why this is known as nuclear transmutation, and as it is artificially done, then it is known as artificial transmutation. But this is different from artificial radioactivity, as in nuclear transmutation there is conversion of one stable nuclei into another, but we are not pointing out that the daughter nuclei is stable or unstable. If the daughter nuclei is stable, then it is okay, but if the daughter nuclei is unstable, then the process will go on because the daughter nuclei is radioactive itself. So whenever a stable nuclei is converted to unstable nuclei, this phenomena is known as artificial radioactivity. The daughter nuclei is radioactive in that case, and the radioactivity developed is artificially developed radioactivity. That's why it is known as artificial radioactivity or induced radioactivity. The process of conversion of one element into another element by artificial means can be done by bombarding of nuclei with high velocity subatomic particles. Now moving on to what are the different nuclear reactions and their types. Actually, nuclear reaction is considered as a process in which one or more nuclides are produced from the collision between two atomic nuclei or one atomic nucleus and a subatomic particle. So the nuclides produced from nuclear reaction are different from the reacting nuclei, commonly referred to as the parent nucleus. Based on different projectiles, we can classify proton-induced reaction, deuteron-induced reaction, alpha-induced reaction, neutron-induced reaction, and gamma-induced reaction. This classification is based on the particle, the subatomic particle, which induce the particular reaction. So there are some examples along the heading. So now come to another classification, that is classification of nuclear reaction based on overall energy transformation. According to this classification, there are five type of reactions: capture reaction, particle reaction, spallation reaction, fission reaction, and fusion reaction. So let's start with the capture reaction. The radiative capture reaction, that is those in which an atomic nucleus fuses with one or more nucleons or nuclei with the emission of electromagnetic radiation. Capture means the overall subatomic particle or the bombarding particle is completely captured by the nucleus, by the atomic nucleus, and both are fused. Emission of gamma radiation or any electromagnetic radiation is held on. It is called capture reaction. In particle reaction, there is bombarding particle is absorbed by the target with the emission of another particle, meaning to say one particle absorbed and one particle emitted. Another reaction is spallation reaction. In these reaction, high energetic bombarding particle is absorbed by the target with the breakup into products of large differences in mass number and atomic number. For example, copper 6329 is bombarded with alpha particle to give a Cl 3770. There is a large difference in atomic number and atomic mass number of copper and chlorine, and the rest of the mass and charge is eliminated in form of protons and neutrons. Now come to the fusion reactions. These are different kind of reaction in which lighter nuclei fuse together and produce a heavier nucleus. The synthesis of element by fusion of light is called nuclear fusion. So as you can see that two atoms of deuterium are fused together to produce one molecule of helium with elimination of one neutron and a huge amount of energy. Similarly, there are some reactions like fission reaction. The fission reaction is splitting of nucleus into nearly two equal parts with release of large amount of energy, as in uranium. When uranium 23592 is bombarded with neutron, then one molecule of barium and another molecule of krypton is obtained, whereas a large amount of energy is released along with neutrons. Such type of reactions are creating nuclear chain reactions. A chain reaction refers to a process in which neutron released in fission produce an additional fission in at least one further nucleus. This nucleus in turn produces more neutrons and the process repeated. The process may be controlled as in a nuclear reactor, nuclear power, or uncontrolled as in nuclear weapons. Hope you remember about the atom bomb. Atom bombs are nuclear weapons that use the energetic output of nuclear fission to produce massive explosion. In fission weapon, a mass is fissile material is assembled into a supercritical mass either by shooting one piece of subcritical material into another by compressing a subcritical sphere of material using chemical explosive. So basically what happens that in atom bomb a particular nucleus is going in fission, and this fission is repeated and repeated so many times, and an uncontrolled type of reaction is developed. Atom bomb is uncontrolled chain reaction. Another example of nuclear fission is nuclear reactor, in which the diagram, as you can see the diagram, that there is a chamber in which concrete chamber in which nuclear reaction is going on. The particle which are used for fuel are uranium 235. The bombarding particles are neutron. Moderator that reduces the velocity of bombarding particle is heavy water, and during the process, as excessive amount of energy is released in form of heat, so that's why there are some coolants are needed, like heavy water, liquid metals like mercury, sodium, and some gases like CO2 or helium. So in nuclear reactor there is some rods of graphite, fuel rods are there, moderator rods are there, and there is a control rod, and the material, the fuel material is placed in the chamber which is bombarded with the neutron, and these neutrons are creating huge amount of energy, generating huge amount of energy. The velocity of neutrons can be determined by using some moderator like heavy water. So hope you understand some basics of nuclear reactions. Then We will meet in the next video. If you want any topic in detail about nuclear chemistry, then you can comment me, and please like, subscribe and share the channel. Thank you.